Okay, so let's continue our here we go. Our talk about probability in sample spaces and events. So we have here what we call the general addition rule. So if I want to find the probability that an event is either in A or B, well, let's try this out here. We know the probability that an event is in A, well, that's 3 out of 9. We know the probability that an event is in B is 1, 2, 3, 4, 5 out of 9. And we know that the probability that an event is in an outcome is in A is 3 out of 9. An outcome is in event B is 5 out of 9. That an outcome is in both events A and B, well, that's 1 out of 9. So if we add these two together and then subtract 1 out of 9, 3 plus 5 is 8, minus 1 out of 9 is 7. And if we count 1, 2, 3, 4, 5, 6, 7, indeed, 7 out of the 9 events are 7 out of the 9 outcomes are either in event A or event B. Okay, so that's the addition rule. If we want to talk about the multiplication rule, okay, here we go. The AND scenarios. First, I got to talk about dependent versus independent events. An independent event, independent events are events where the outcome, whether or not one of the events happens is not affected by whether the other event happens. So, an example of independent events. Let's say event E is it rains tomorrow. Event F is, I don't know, getting an A on a test. Well, it's assuming your study habits have nothing to do with the weather. Those are independent events. Or roll a 6 on a die. Q is flipping a heads. These two events have nothing at all to do with each other. Whereas, let's say, dependent events, events that are not independent. E is temperature is below 30. Okay, drag this over here. Okay. Temperature is below 30. And event F is it snows. Well, whether or not it snows does have a little bit to do with temperature. So I can say these events probably are not independent. So that's what we mean by dependent versus independent events. So as a quick example, if I define two events here, probability of event A is 0.5, probability of event B is 0.9, 90%. And assuming they're independent, A and B, probability of both of these events happening is 0.45. And if that's the case, then probability of A or B is probability of A plus probability of B minus probability of A and B. So this is going to be 0.5 plus 0.9 minus 0.45. This is 1.4 minus 0.45. So this is 0.95. 95% or 0.95 probability that either one of them happens, a 45% probability that they both happen. So that's just a quick example of what I mean by and or events. Suppose the probabilities now what does this be? This line here mean? It means conditional probability. Conditional probability basically is the probability that one event occurs if it's a given that the other event has already occurred. So and so that's what that line, that's what that slash means. For example, the probability of rain on any particular day might be, let's say, 0.2. Or I could say the probability of rain, let's introduce some given information. If we know that it's cloudy outside, well, that's going to increase the probability of rain. I mean, right now, this might say it rains 20% of days in a particular month. But if we already know it's cloudy, and I'm just making up arbitrary numbers here, let's say 75 probability. Because now so rain and clouds are dependent events. How can I tell they're dependent events? Well, other than, obviously rains and clouds are dependent. But aside from that, if I just replace it with generic events, how can I tell they're dependent? So, how can I tell these are independent? Well, if two events are independent, that means I can put this in terms of rules of probability. That the probability of A given B is equal to the probability of A. Saying this out in English, it's saying who cares if B has occurred or not? Whether A or not occurs or not has nothing at all to do with whether B occurs. So this dependence is irrelevant. So is that the case up here? A given B is one probability, and A is another probability. These two probabilities are different. So because this condition is not met, I will conclude that A and B are not independent events. Okay, so we've covered dependence, independence. The last thing to discuss here, which I left out earlier, is that of disjoint events. So I'm going to say A and B are disjoint if the probability of A and B both occurring is 0. This is basically a definition of disjoint events. So A and B cannot both occur. Another way of saying disjoint events are mutually exclusive. So let's take an example of two events that are disjoint. Event A event A is tomorrow's high temperature will equal 75 degrees. Event B is it will snow. Those are disjoint events. They can't both happen. So by definition, I would say they're disjoint. The probability of those events can happen. If I look at a Venn diagram of A and B, what happened here? If I look at a Venn diagram of two disjoint events, A and B, the diagram would look something like this. You see, these two events have no common outcomes. Even numbers and odd numbers. You know, so 3, 4, and 5. So there's no events in common. So basically, that is going to give us a special addition rule that if A and B are disjoint, then the probability of A or B, now I can simply add the probabilities, because the probability of A and B is 0 in any event.